Okay, hi class. Assalamualaikum warahmatullahi wabarakatuh. So now let's continue on the next topic, which will be the last topic for chapter 3, that is voltage regulator. So inside your voltage regulator, we do have what we call Zener diode. So Zener diode is a special type of diode. So the normal diode that you have is like this, right? Where your V gamma is equal 0.7 volt. And when it is reverse bias, there will be no current. At your forward bias, there will be a current. But Zener diode here is a special diode. Why we call Zener diode? Because it is a highly doped material. When we're talking about highly doped material, what does that mean? So let's recall back what is your diode. So your diode consists of P and N side by side, right? So when it is normally doped, means your whole majority carrier and your electron here is in a normal numbers. But when we're talking about Zener diode, it is highly doped, means there will be a lot of hole and a lot of electron inside. So when there is a lot of hole and electron, it will make your depletion region become smaller. Means here your depletion region become smaller compared to your normal diode. Okay. So when this happens, at your reverse bias, so at your normal diode actually, when it is reverse bias, you need what we call peak inverse voltage, the maximum voltage here before it start to break down, right? So this is what we call avalanche. But in your Zener diode, we are going to purposely make it function at the reverse bias. Means since the depletion region is smaller, means even at maybe 10 volt, you can directly having some current flow here. So this is what we call not avalanche, this is what we call Zener breakdown, or we call here Zener breakdown. We want this to happen because this is a special type of diode where at the reverse bias there is a current. When we call this one 10 volt, is actually when it happened at the Zener voltage, there is a current. But at your normal diode, you need a very high voltage, right? So this is what we call avalanche. Avalanche, we don't want this to happen, but in your Zener diode, we want this breakdown to happen. So this is what we call Zener diode. So as an explanation here, so breakdown voltage you can relate to what we learned previously, where we have PIV. What is PIV? Minimum the maximum voltage before the diode start to break down. So when this happen at the reverse bias, where we have PIV here. So this is what we call avalanche breakdown. Why avalanche happen? Means when you have a very high voltage here, it will provide energy, right? So when it provide energy, it will break the covalent bond and we start to having some current. But we don't want this avalanche to happen. But in your Zener diode, because it is a highly doped, so the keyword here is highly doped material. So even at a small voltage at the reverse bias, we can easily have some current. So this voltage we call Zener voltage. So what happened at your Zener diode? At a forward bias, means here, at forward bias, it will act like a normal PN junction. But at the reverse bias, for normal diode, reverse bias no current. But for your Zener diode, at reverse bias, it will act at the breakdown region, means we will have some current. So this current happen during the Zener voltage, or we call here breakdown voltage. So how we draw the symbol of your Zener diode? So let's see, this is your Zener diode. So there's a Z symbol here, like this. So here is your Zener voltage. And if we compare to your normal diode, we don't have any Z there, right? So here will be plus, here will be minus. At their normal condition, means at the forward bias, Zener diode will happen normally. But at the reverse bias, here will be plus and here will be minus. Okay, so this is what happened to your Zener diode. Okay, if we go back to the IV characteristics, so means this is what we call Zener breakdown. Zener breakdown. And we name here VZ. So the breakdown of the Zener voltage is nearly constant. It happened at where? At the reverse bias. So this VZ will play role at your Zener diode. So it can be used as the voltage regulator or voltage reference circuit. Okay, so if we combine the avalanche and the Zener breakdown, so here is the avalanche that we don't want this to happen to your diode. If this happen, your diode will be damaged. But in your Zener breakdown, we do want this to happen because your Zener diode just now, this is your Zener diode, is a special diode where it is highly doped. At forward bias, Zener will do like normal. So it will have current at the forward bias and it will also have current at the reverse bias when it reach the Zener voltage. So this is the symbol of your comparison of your normal diode and your Zener diode. So there is a Z symbol here. It will be plus and here will be minus at the reverse bias. So as I highlight here again, at the forward bias, it will act like a normal PN junction. At the reverse bias, it will conduct current at your VZ, that's we call Zener voltage. Okay, so as the summary, how we compare the normal diode and the Zener diode. So avalanche happened at the normal diode. Zener diode is having Zener breakdown. So it consists of a highly doped. For normal diode is normally doped. Highly doped will lead to the smaller depletion region and it will have a reverse breakdown at the smaller voltage. That voltage we call Zener voltage. And for your Zener diode, it primarily used for voltage regulator that we will discuss in the next topic. And for your normal diode is for rectifier. What is the function of rectifier? To convert two polarity, that is plus minus, to become one polarity. So this one we use normal diode. For voltage regulator means, let's say we have this graph here. If we change from the semicircle here to a straight line, and how we are going to use this one? By using Zener diode. Okay, one of the main application of the Zener diode is what we call voltage regulator. So for this one, we are going to discuss in the next topic. So I will just introduce you here. What is the voltage regulator? Is to supply the constant voltage. How we can supply a constant voltage? By having Zener diode inside your voltage regulator. Why we need this constant voltage? Because your input here may be a variable source. So it may have some maximum value and minimum value. So in order to regulate the voltage, you need Zener diode and your output will become a straight DC supply. Okay, so that's all for this video. Assalamualaikum warahmatullahi wabarakatuh.